Good morning or good afternoon. I would like to welcome everyone to Cisco Support Community Expert Series Webcast, Multicast on Cisco WLC. We're glad to have you with us. A few housekeeping notes to begin. As you've entered the WebEx console, you either joined us by audio broadcast or by phone, which is automatically muted. Because of our large audience today, you will remain muted throughout the event. When you have a question, please feel free to enter it into the WebEx Q&A panel as you think of them. You can find the Q&A panel on the right-hand side of your console. Please leave the WebEx chat window for communication to our WebEx facilitator for any technical problems or issues you may be experiencing. We would appreciate your input regarding today's webcast, and a short survey will appear once you close the browser at the end of this event. At this time, I'd like to introduce our host for today, Satish Chandran.
Thank you, Louis. Hello, everyone, and welcome to Cisco Support Community. Today, we present a live Cisco Support Community Expert Series webcast, and our topic today will be Multicast on Cisco Wireless LAN Controllers. My name is Satish Chandran, and I'll be moderating today's event. Our expert joining me today is Maitri Bhagwan. Maitri is a customer support engineer at the Cisco TAC in Bangalore, India. She has 4 years of experience and has worked on a wide range of Cisco wireless products and technologies such as autonomous iOS, access points, wireless LAN controllers, wireless VoIP phones, wireless control systems, network control systems, and mobility service engines. She is also an expert in LAN switching technology. Welcome, Maitri.
Thank you, Satish. My pleasure. Today, I'm also going to introduce our expert two more panelists who are going to be the questionnaires for today's session. My colleague Sharad and Madhuri, both are TAC engineers in Cisco Wireless TAC.
Hi, everyone.
Hi, everyone.
Great. So now I'd like to briefly outline the format for today's Expert Series webcast. Our expert will start with a brief presentation on Multicast on Cisco Wireless LAN Controllers for the first hour of the program, and then we will provide an answer to the questions that was asked in some of the promotion. What is the connection between Cisco Wireless LAN Controllers and Apple? Stay tuned for that. Then we'll dive into a live question submissions from the audience for the remainder of the event. During our live presentation, you may submit our technical questions to be answered by a presenter and the technical panelist, Sharad and Madhuri, using the Q&A box, which is on the right-hand side of the console. The team of technical experts is well-versed in Multicast on Cisco Wireless LAN Controllers. So please begin posting your questions now to give us the best chance of answering them. And if you experience any technical issues, please post your questions in the chat window. So we'll be asking some of the polling questions during this webcast, and we highly encourage you to participate by answering them. And you may download a copy of today's PDF presentation using the link in the chat window. Now let's get started with today's event. So all attendees that join the event will get 125 Cisco Preferred Access Points, and there will be a raffle for one lucky winner who will get $50 Amazon gift card. So let's start with a polling question for the audience. The question is, are you planning to implement Multicast on the wireless network? Option A, I have already implemented it. I'm looking to implement it soon. And option C is I would like to learn more about it. Please take a moment to answer so that expert can tailor her presentation to your needs. So the poll is open on the right-hand side of the console. So make sure you submit your questions and we will answer them later in the webcast. Now I'd like to hand over the mic to our expert Maitri for the presentation. Over to you, Maitri.
Thanks, Satish. Hello, everyone, and thank you for attending this webcast. Before we go over today's presentation and the agenda, I would like to just outline the scope of this webcast. We are going to talk about how Multicast works on Cisco Wireless LAN controllers, the configuration required to support Multicast, and we'll also, troubleshoot some, common issues. All the terms explained are with respect to wireless and how it works in a wireless environment. We do have some basic configs on the wired network, but it's very limited. This is the agenda of today's session. We are going to look at why we need wireless multicast, What are the different modes of multicast? What is broadcast forwarding? What is IGMP snooping? And also some guidelines for configuring multicast. We will also look at the required controller configs and some basic wired side configs. We will later look at some commonly seen issues while implementing multicast on wireless and how we can fix those. We'll finally open up for the Q&A session. Why do we need wireless multicast? As we know, more and more customers today are implementing BYOD in their networks. BYOD stands for Bring Your Own Devices, where users can bring in their own personal devices, plug it into the network, and they'll get connected. With the increase in such deployments, it becomes necessary that your wireless network is also capable of supporting the different type of client devices that the users have and also the features they use. The most commonly used BYOD devices today are iPads, iPhones, etc. They work using the Bonjour protocol, which is 224.0.0.251, and it needs multicast enabled on the wireless. Some of the other common applications where wireless multicast is used is for media streaming, generally in educational institutions and large enterprises, audio and video conferencing, and file sharing applications. Modes of multicast. IP multicast was introduced on Cisco Unified Wireless Network Release 3.2 onwards. There are two basic modes of multicast: Unicast mode and Multicast mode. Okay, I see that the results of the poll are out, and I can see that 73% of the audience would like to learn more about multicast. That's great to know because this is the right session for you. We'll be covering a lot on the basics, so it would be easier for you to implement this in your network. Multicast-Unicast mode. This was the mode that was initially introduced on the controller. In this mode, the controller forwards all the multicast traffics to all the APs associated by making copies of each multicast packet and sending it to each and every access point. Depending upon the number of access points connected, the controller will have to replicate each multicast packet for each CAPWAP tunnel. So as you can guess, this consumes a lot of processing power and causes an overhead on the controller. Apart from this, we also see a flood of large number of duplicate unicast packets. In order to overcome the disadvantages of multicast-unicast mode and also to optimize the multicast performance on wireless, we then came up with a multicast-multicast mode. In this mode, instead of using unicast to send each packet across CAPWAP tunnel to each access point, an LWAP AP multicast group IP was used. What this does is just a multicast IP that is configured on the controller. The controller will send all the multicast traffic directly to this multicast group IP. All the access points on the controller will join this multicast group using an IGMP join request, and as soon as they join, they will start receiving the traffic. In an LWAP multicast group, the controller is going to act as the multicast source, and all your access points will be the multicast receivers. You might have a lot of controllers in your network, but your access points might see a lot of packets from other controllers as well, but the access points will only process those IGMP queries that comes from the controller that it is associated to. This is a simple presentation of the multicast-multicast mode. As you can see, we have the wireless LAN controller where one multicast packet comes in. The same packet is sent out to the multicast group, so we can see that the controller is not replicating any of the packets here. Once the packet reaches the multicast group, it then uses the multicast method to send the packets to all the access points on the controller. The access points then, depending upon how many clients it has connected, it will replicate the packets and then send it across. There are various ways and various paths that a multicast packet can take, depending upon whether the source is on the wired side or on the wireless side. So, assuming the source is on the wired side, when the controller receives a multicast packet from any of the client VLANs on the first hop router, it will transmit the packet to the LWAP multicast group via its management interface. The multicast-enabled network will then deliver all these packets to all the access points across the network that have joined this LWAP multicast group, and the access point will then deliver all these packets to the clients and replicate them as required. If the access point has more than one VLAN that is associated to the VLAN interface where the multicast packet was originally received, then the AP will transmit the packet over each WLAN. And in case the access point has dual radios and there are clients listening on both the radios, then the access point will send the packet out both the radios as well. Assuming your multicast source is another wireless client, in that case, the initial multicast packet will go as multicast from the client to the AP. The access point will then encapsulate this in the CapWAP tunnel and send this as a unicast to the controller. The controller will then make 2 copies of the multicast packet. One copy is sent out of the WLAN that is associated with this, the VLAN that is associated with this WLAN. This way, it will get to send the traffic across the wired network for all the wired clients that are connected. The other copy is then sent to the LWAP multicast group IP, where all the other wireless clients can receive it to their access points. Broadcast forwarding. Broadcast forwarding is a term that is used often in conjunction with multicast. This is just a feature that tells the controller how to handle the broadcast packets that it receives. If broadcast forwarding is enabled on the controller and the multicast mode is set to unicast, then the broadcast packets, each broadcast packet is also converted as a unicast packet and then sent. As explained earlier, this will again cause a flood of traffic in the network. But if broadcast forwarding is enabled on the controller and the multicast mode is used, then the broadcast packets will also use the LWAP AP multicast group IP address to send all the traffic, and the access points will replicate them. IGMP snooping. IGMP snooping support was introduced on Cisco Wireless LAN controllers from version 4.2 onwards. Using this, the controller is going to gather all the reports from all the clients who request traffic from that multicast group. This is a way of optimizing how many multicast packets are replicated, because if there are access points that do not have any clients requesting for this traffic, then the access point will not replicate the multicast packets and will just discard them. So when the clients send IGMP reports to the controller will analyze these reports and it will create a unique MGID on the controller for each multicast group and its corresponding VLAN number. The reports will have a source address, which is the interface address of the VLAN from which the client traffic is received. An access point MGID table is also created on all the access points associated to the controller along with the client MAC addresses. So this way the access points will know how many clients are listening to the data and it will forward the traffic across the corresponding WLANs accordingly. When the controller receives multicast traffic for a specific group, it will forward it to all the access points. But when IGMP snooping is enabled, only those access points that have clients listening on that group will forward the traffic on that WLAN. Layer 3 multicast packets will be forwarded with an MGID that is created based on the ingress VLAN and the multicast group IP. Layer 2 multicast is forwarded with an MGID that is unique for the ingress interface, as in this case we do not have a multicast IP address. This is a screenshot that shows the example of a layer 3 MGID on the controller. We can see we have the group address 224.0.0.251 created for VLAN 20. It shows that we have users on VLAN 20 that are listening for this traffic. And this is the unique MGID that is created on the controller. So this way we will know whether your clients are actually receiving the traffic or not. You can also see 239.225.225.250. This is the controller local multicast group IP, and this is the MGID created. The screenshot shows the example of a layer 2 MGID. As we can see, we have the layer 2 interfaces, the corresponding VLANs, and the MGIDs that are created. Before we look at the configurations of multicast on controllers, we would like to check at some of the basic guidelines that we should keep in mind before we configure multicast. Cisco recommends to use multicast addresses from the block 239.0.0.0. This is the reserved block of multicast IPs for use in private multicast domains. Within this range, we have to make sure we do not use the addresses 239.0.0.x or 239.128.0.x, as these addresses are linked local MAC addresses, and using these addresses might cause the multicast traffic to get flooded out of all the switch ports. The LWAP multicast address configured on the network should be different for each controller in the network. If you're going to have the same multicast group IP configured on all the controllers, then the traffic from each and every controller will be sent across the network and might cause a storm. Multicast applications should not use UDP port numbers 12222 to 12224, as the controller will drop any multicast traffic sent to these ports. Now we will look at the configuration on the controller. From the configuration is quite straightforward. It's just a few clicks and will be all set. From the GUI, you just go to the controller tab, and then you have the general option there, where you have the option to enable multicast in the Multicast-Unicast Mode or the Multicast-Multicast Mode. If we are choosing the Multicast-Multicast Mode, then we need to enter the multicast group IP address that we want to use on the controller, that is local for the controller and its access points. Now, while assigning this IP address, we have to make sure that we follow the guidelines that we saw on the previous slide. Next step is to make sure broadcast forwarding is enabled, to make sure that the broadcast packets are also sent without any issues. The final setting is to go under controller multicast option and enable the multicast globally on the controller using the global multicast mode option, and also enable IGMP snooping. This is a screenshot from the controller which shows the configuration. So we can see that this is the AP multicast mode, which is set to multicast, and this is the group IP which I have assigned, 239.1.2.3. Similarly, you can assign any IP you want, as this IP is just going to be used as a local IP within your network for communication between the controllers and the access points. This IP is not going to be used anywhere else, but we just have to make sure that it is not configured on any of the other controllers. The next thing that you have to check is the broadcast forwarding option, which in this case is enabled. Then we go to the controller option, multicast, and make sure the global multicast mode is enabled. And then we also have to enable the IGMP snooping option. With IGMP snooping, we have the timeout and the query interval values. The controller just determines this to identify whether there are any clients that are requesting for multicast traffic on a specific WLAN. Wired configs. Now that we are done with the configuration on the wireless part, it is important that we also make sure the wired part is configured correctly. There are a lot of times when we see issues where the wireless part is configured fine, but still multicast does not work because we are missing some kind of setting on the wired part of the network. So first very important thing on the wired side is to make sure that multicast is enabled on all the layer 3 hops from the source to the destination. You might have various routers and switches and multiple other devices in between. You have to make sure all of them are configured to allow multicast traffic. On Cisco iOS, we can just use the command IP multicast-routing distributed in the global config mode, and this will enable multicast globally. Once this is done, we have to identify the subnets on which we want to enable multicast. We do not want to enable this on all the available subnets. We just want this on those subnets where we will be having the source, destination, or the client traffic. The most important VLANs on which we have to make sure it is enabled is the multicast source VLAN. This can be any client on the wired or the wireless segment. The destination client VLAN, all the VLANs where you have clients that will be listening to this multicast IP. The AP VLAN, the VLAN in which all your access points are present, and the controller management VLAN. In some of the cases, if you have AP manager interfaces which are on different subnets, you'll have to make sure you enable multicast on that as well. We can use dense mode or the sparse mode or the sparse dense mode to enable multicast on the wired side. This basically depends upon your requirement. If you have a very huge network, you can go for the sparse mode or the sparse dense mode. For a simple network, you can just go for the PIM dense mode. Here is a sample config. So we go into the switch, layer 3 switch or the router, and just say IP multicast-routing distributed. Then we identify the interfaces, which in this case are VLAN 10, 20, and 30, and we have enabled IP PIM dense mode. To verify that multicast is enabled correctly, you can just do a show IP PIM interface. This will show you all the interface addresses and whether multicast is enabled or not. Verification commands. Once multicast is enabled, we can use the following commands to verify. We can just do a show run, include multicast. This will tell us all the multicast commands enabled on the device. And we can do a show IP mroute, which is a very important command. This will tell us which are all the incoming interfaces from which the traffic is arriving and which are all the outgoing interfaces to which the traffic will be sent out. IGMP snooping is a feature that is enabled by default on all the switches, but in case it is disabled, we can just use the global config command IP IGMP snooping to enable it.
Okay, so before we get back to the presentation, I'd like to take a moment to ask another polling question. The question is, what is your level of experience with troubleshooting wireless multicast? Option A, I know the concepts well and know where to look for the issue. Option B, I know the basic concepts and research further online to get more info and try to fix it. Option C, I'm not very familiar with it and open a tag case if I need assistance. And option D, I have never tried this before. So please take a moment to record your responses. Make sure to submit your questions as we have a panel of experts ready to answer them.
Okay, I can see we have the results of the polling question. We have 7% who say that they know the concepts well. We have 43% who say they know the basic concepts but need some more info. 6% who are not very familiar, and 44% who say that it's a totally new concept to them. Okay, we will learn more about this in the upcoming slides. The next few slides, we're just going to talk about how we can troubleshoot multicast. We are going to talk about how we can isolate the issue, because we need to know where exactly the issue is in the network. Because if wireless multicast does not work, it does not necessarily mean that the issue is always on the wireless side. There are a lot of other issues, lot of other reasons why it might fail. Then we will look at troubleshooting on wired side when we know that the issue is there somewhere on the wired network. Then troubleshooting commands on the controller, and then we'll see what debugs command we can use. Troubleshooting multicast. As explained, when we are not receiving multicast stream over wireless, first we need to isolate if the issue is on the wired side or the wireless side of the network. It could be depending upon where your multicast source is, whether on the wired or the wireless side, the issue can be anywhere. To verify this, what we can do is we can keep the source and destination both as wired devices and test if that works. Say you have your multicast source on VLAN 10 and destination is a wireless client on VLAN 20, then instead of having it as a wireless client on VLAN 20, we can just have it as a wired client on the same VLAN and see if that works. The main reason for doing this is when we are just having both the devices as wired, we are eliminating a lot of intermediate hops like the AP subnet, the controller subnet. So that way we can make sure that at least on the source and the destination subnets, we have multicast enabled correctly. In case we find out that the wired multicast itself is not working fine, then we have to check the configs at each and every hop and make sure the source and destination at each and every hop between the source and destination, and make sure multicast is enabled correctly. By this, what we mean is we can have multiple hops between the source and the destination, various routers and switches in between. It could be possible that somewhere at some specific hop we have not configured it correctly, which is causing the multicast packets to drop. Some of the common commands that we can use to verify on which hop the issue could be is show IP PIM interface, which will basically show us whether the multicast modes, the PIM mode has been enabled on all the required interfaces and required subnets. Then we need to do a show IP M route. This will tell us if the traffic is coming correctly into the device and if it is going out correctly out of the required interfaces. The third option, the third command that we can check is show IP IGMP. This will tell us what is if IGMP has been correctly enabled. The next scenario is assuming your multicast works fine on wired side. You plug in a client in VLAN 10, another on VLAN 20, both are wired, and you know that everything is working fine. That is when you start checking that probably there could be something wrong on the controller that is causing this. In this case, what we can do is, first thing is to make sure the controller is configured correctly for multicast. All the basic level checks like make sure the multicast or the unicast mode is set correctly, make sure broadcast forwarding is enabled, check that the global multicast mode is enabled, and things like that. Once we have verified that the controller is configured correctly, we can then isolate the issue by reducing the number of hops between the source and the destination. So say for example your multicast source was like 3 or 4 hops away, and then your multicast destination is a wireless client. In that case, what you can do is you can try to see if you can plug in the multicast, the source device directly into the switch where you have your APs plugged. So this way you're eliminating a lot of other devices on the path, and we are just dealing with those 2 or 3 devices, and it is easier to isolate where exactly it is misconfigured, and we can check that. If there are multiple controllers in the network, it is recommended to use a unique multicast address. There are times when we see a flood of multicast traffic, and there are times where we have also seen that the high CPU on switches, because multicast various controllers have been using the same multicast IP and the traffic is flooded all across the network. So in order to avoid this, we will make sure that the IPs are configured separately on each controller. Once all this is done, we can try by placing the multicast source and destination on a different VLAN and check if the issue is fixed on that. So these are just various methods that we can take to isolate where exactly or which VLAN exactly the issue is, and then we can make sure we follow the correct configs later. Another important thing that could block multicast traffic is peer-to-peer blocking, which is enabled on the WLAN under the advanced mode. So if you have this enabled, then all the multicast traffic is going to be dropped. So make sure this option is disabled. Some of the important commands on the controller to verify the multicast configs. You can do a show network that will tell us which mode is the multicast using. It will also tell us whether broadcast forwarding option is enabled or not. Then we can check the L2 and L3 MGIDs. These are one of the very important things that helps us a lot of times. This will tell us exactly whether we have clients listening on some interface or not. That way we will know whether multicast is working or not. So if you do not have any clients, or it has been a while since any client has requested traffic from specific multicast group, then the controller will automatically delete the MGID. So in that case, we would not see any entries. If you want to see the detailed information about a specific MGID, then you can just use the Show Network Multicast MGID Detail option for that MGID. We do not have too much in-depth debugs, but we just have debug broadcast star enabled, where star could be any option like events, packets, detail, etc. So you can use all these various options to look at the debug commands and isolate the issue. Apart from this, some of the most common issues that we see on multicast is issues where client devices are unable to send traffic, or issues with only certain kind of devices. The most common issues that we face are with Apple devices like iPads, iPhones, or Apple TV or AirPlay does not work, and such issues are the most frequent ones that we get, where generally it turns out that there is an issue or some kind of incompatibility between the source, between the clients and the controller, or generally it's an issue with the misconfig where the multicast is not configured correctly somewhere on the wired side. There are cases where it's mainly an issue with the multicast routing, because Bonjour at times faces issues with when the source and destination are on two different subnets. Some of the common things that you can do is to make sure that you take a packet capture from the clients. There are certain type of clients like passive clients, scanners, RFID, guns, etc. These client devices at times might not send IGMP reports. So when you have IGMP snooping enabled on the controller and the clients do not understand what this is, then they might not receive the traffic. With such clients, it is a good idea to take a wired or a wireless sniffer capture somewhere from the client or from the controller switchboard, where we can confirm to see if the client is actually sending the IGMP reports. When we are dealing with such clients, it is recommended that we turn off IP IGMP snooping option and also the IGMP snooping on the controller. Generally, there are few instances where only certain multicast applications do not work. To verify if it's an application-specific issue, we can try to use some other kind of a multicast streaming device as the source, and we can see if it works fine with that. VLC media player is a very good example which can be used to source multicast traffic, and we often use that for simulation in labs. Another example could be any kind of a multicast generator. We have a lot of options available on the internet. We can have a multicast generator installed on your PC and then mention which is the group IP to which you want to send the traffic. Then you can have another a multicast traffic receiver installed on another PC which will receive all this traffic. And by analyzing the Wireshark captures from the source and the destination, we will know if the multicast traffic is being sent and received correctly. So that way we will know that if it works with a third-party multicast device, then what we can do is we'll know that it's an application specific. So we can go and check what exactly is that's causing the issue with that application and make the required config changes. This is a screenshot that I have taken from a multicast traffic generator. This is something that we use in lab frequently for recreates. It's quite simple tool that does nothing but just send continuous source of multicast traffic, something more like echo packets. It keeps sending it to the specified multicast source destination group. So in this case, I've configured 239.1.2.3 as my destination IP address, and then I just click on OK, and then we can just do a start. So as soon as you click on start, and if you have the Wireshark running, you can see the continuous stream of multicast traffic sent to this destination group. On the other PC, you would have like a multicast traffic receiver, something like this. What you can do is, in this, you will have to specify which is the host address from which you are listening to the traffic. So in this case, our multicast generator is sending traffic to this destination IP. So your multicast receiver will then join the same multicast group using 239.1.2.3 and then click on join. The minute joins, you can start seeing the multicast traffic from that group. With this, we come to an end of today's presentation session. Hope you found this useful. Now over to Satish.
Okay, so time for another polling question. So was this session helpful in clarifying your queries on wireless multicast? The option A is have additional questions. Option B, it helped me understand the concepts but need more detailed explanation. Option C, yes, it helped me and I can now implement this in my network. Please take a moment to record your responses. I see. So we have maximum percentage saying that it helped me understand the concepts but need more detailed explanation. Okay, that's great. So we'll try to do some follow-up sessions on the same topic. But when we post the recording and when we post the FAQ document from this webcast, feel free to use the comment section to ask any queries that you have related to it so that Maitri can actually respond to that. And this slide talks about some of the references document that you can refer on the very same topic. These are all cisco.com documents. All right, so thank you, Maitri. It was a great presentation. And also thank you everyone for participating in the event polling. Now it's time to answer some of the questions that our viewers have submitted today. And by the way, if you can't stay with us for the Q&A, please be sure to click on the evaluation that will pop up once you close the browser to let us know how the session met your business needs and expectations. You can also access the survey. Shortly, we'll post the survey URL in the chat window. Okay, so let's start with the Q&A and let me take the first question. So I think it's referred to slide number 6 that says, this also floods the network with large number of duplicate unicast packets. Can you explain little more on how it floods and duplicate packets on wired network?
Yeah, definitely. So I think slide number 6 was where we were talking about the modes of multicast and what are all the disadvantages. So with Multicast-Unicast mode, what happens is that we do not have, the controller is just going to send multicast traffic to all the access points. So we do not have a definite method or any method of determining whether the clients actually need the traffic or not. So since, say, you have like 300 access points on the controller, then the controller is just going to replicate 300 packets, and access points will again replicate them depending upon the requirement. So we just see a lot of multicast packets going back and forth in the network, but not all of them are required and a lot of them might just be discarded. So it just consumes a lot of bandwidth. So this is exactly what is the limitation of the Multicast-Unicast mode. So to avoid this, we are going for the Multicast-Multicast mode, where we are using the multicast group IP, wherein we can limit which access points and which clients receive the traffic. Thereby, we don't have too many redundant copies in the network.
Okay, thank you. Another question that says L3 MCAST packets are forwarded in the MGID that is unique for the ingress VLAN and the MCAST groups. And L2 MCAST is forwarded with MGID that is unique for the ingress interface. So can you explain a little more on this?
Okay. Yeah, so I think this is more in reference to how the IGMP snooping works on the controller. So what happens is that when any traffic comes to the controller, say for example, let us take the multicast source is on the wired side. When a traffic is going to come, the controller needs a way of identifying which are all the VLANs or which are all the WLANs where we have clients and how many clients are requesting the traffic. In order to deal with that, the controller makes an MGID table, and also the MGID table is also created on all access points along with the client MAC addresses that request traffic. So in this MGID table, if we are doing layer 3 multicast, what we have is we have which multicast group has clients on which VLAN. So this way the controller will know that using this MGID, the controller will know to which WLAN and to which clients it has to send this traffic. Similarly, we have layer 2 multicast, where we just know which are all the VLANs on which we have clients that are waiting for traffic from this particular multicast source.
Thank you, Maitri. Let me take another question. What is IGMP timeout in WLC GUI, and is default value 60 seconds?
Yeah, IGMP timeout is basically a value entered on the controller that is used to determine if there are any clients that are requesting for the traffic or not. So the controller will send 3 queries in one timeout interval value to the clients to determine if the client is still active and listening to the multicast traffic. In case it does not hear back from the clients after 3 queries, then it will automatically delete the MGID that it has created from the table. So it now knows that this client is no longer active, and hence I can stop sending multicast traffic to that client.
Okay, thank you.
Yeah, I think the follow-up question was what is the default value? That should be 60 seconds by default, and it can be changed from any value from 30 to 7200 seconds.
Okay, so let me take a few more questions. The question is video stream need to be enabled for proper function of multicast?
No. Video streaming is something that will actually, multicast is something that would actually help for video streaming, but video streaming is not actually mandatory for multicast to work. So it's the other way. Multicast will help video streaming, but if you are not using video streaming, then it's not required.
Okay, great. Another question that says, is it mandatory to have multicast enabled on BYOD?
It depends upon what kind of clients you have. For example, like I explained, most of the common BYOD devices that we see today are Apple devices. So these devices use Bonjour, and Bonjour is 224.0.0.251. So since they are going to use multicast for most of the applications and for sending traffic across, if your controller is not going to support multicast, then none of these applications will work. So most of the BYOD devices today do use multicast applications, video streaming, file sharing applications, etc. So it plays a major role in BYOD networks. So yes, I would say that it is very important to have multicast enabled.
Okay, thank you. Another question, how is the Bonjour supported in Flex Connect mode?
Okay, Flex Connect mode, or HD mode as referred to in earlier versions, is one where access points are located at a remote site and connected across a WAN network. So generally customers have questions as to how will multicast traffic be sent with this mode. The answer to that is, if your access point is going to be a local access point or an HREP or Flex Connect access point in a centrally switched state, then your multicast traffic will use the multicast group IP to send all the traffic. But in case you have the Flex Connect mode and local switching, then your multicast traffic will just follow the Multicast-Unicast mode. So there is no multicast happening there.
Okay, thank you. And there's one question that says, I assume the disturbed keyword is needed on CAT 6500. Smaller switches or routers use IP multicast routing only. Is that right?
Yes, that is correct. So this is a sample example that was taken from certain platforms. But yeah, you're right. Smaller platforms, you can just enable IP multicast-routing, and that should enable it.
Okay, thank you. And one question is, are multicast packets handled by CPU of wireless LAN controller for forwarding plane?
Multicast packets are handled by the CPU for certain platforms, but some of the later platforms that we have, like 5500s and all, they have this what we call as fast path. So that will enable them switching packets quickly along the fast path, so it doesn't actually have to hit the CPU. So depending upon which controller platform you're using, if it's like the earlier series like WISMs and 4400s, then it is CPU switched. If not, it is fast path switched.
Okay. I see many users asking for the slides. So the document ID, let me check the document ID. It's 28753, and this link will be pasted in the chat window so that you can download the presentation from there. And let me take a few more questions that are coming in. So, Maitri, the question is, how can we prioritize multicast traffic in wireless network?
So by default, multicast traffic is generally sent with a best effort QoS, so which is with a tag of 0. So if you want to specifically prioritize, then you have to make sure that you have specified and given it the appropriate priority. But most of the time, what happens is multicast packets, as we know, they consume a lot of bandwidth. So there are other important much important traffics that are generally given priority over multicast.
Okay. Let me take one more question. That is, what is IGMP snooping? Can you elaborate more, just for the basic understanding?
IGMP snooping is nothing but a term that's available on switches, just to determine how many clients are actually requesting for packet, and depending upon so what will happen is every client that wants to join the group will request it will send an IGMP query, and through this the switch will learn the client's MAC address and it will create an entry. On controller, how this works is that the controller will get IGMP reports from clients. It's very similar to how it works on a switch. It will get the reports from the clients. The controller will then form the MGID table that we talked about earlier. So it will form the MGID table and will keep a list of how many clients, what are all the client MAC addresses, and which are all the VLANs on which it's requesting for traffic. Depending upon whether there are clients listening or not on that VLAN, the controller will send the traffic. It also has the IGMP timeout value. If it eventually finds out that there are clients that are no longer listening to the multicast traffic, then the controller will delete the MGID from the controller multicast table.
Okay. I see some of the users have been posting questions in the chat, that is technical questions, but let me take one question that says, is there a way to limit multicast for wireless clients? And he means by that the command that is configurable on AP.
Okay, is there a limit? Can you please repeat the question?
The question is there a way to limit multicast from wireless clients? And he means the command that is configurable on AP.
No, there's no such commands to limit multicast from the clients. The clients will send the traffic. The controller will determine whether it has to, how it has to forward the traffic. But there's no such thing to determine the client traffic, to stop it from sending.
Okay. So, all right. Let me take one more question. I know the technical panelists are responding to the questions that are coming in. Okay, when is Cisco going to integrate Meraki's feature for native support for Bonjour in its own controller?
That's a great question, but I think I'll forward this to one of the technical panelists, Sharath here, who is really eager to answer this question. Sharath?
Okay, so we just completed the Meraki acquisition. So we might still need another 4 to 6 months to actually get this feature into Cisco portfolio. So as of now, you can look forward for this feature after only the 4 or 6 months.
Okay, thank you, Sharath. So, well, technical panelists are still standby, so you can post your questions in the Q&A. But let's conclude this Q&A portion for today's event. So we'll have a raffle for prizes among the listeners that complete their evaluation survey. And if you're lucky, you can win, all the attendees will win 25 CPA points, and one lucky winner will win the $50 Amazon gift card. And like I mentioned earlier, the survey link will be posted in the chat window or when you exit the session. And moving on, as I mentioned in the chat, the recording of this session and all the questions that came in via the Q&A panel will be creating a FAQ document, and we'll be posting the recording in the expert corner under Webcast community in Cisco support community. So it will be posted within next 5 business days. And if you have not explored the Cisco support community, take a moment to check out this excellent resource. And now there is an upcoming Polish webcast that is on Tuesday, January 8, 2013. The topic will be WAN acceleration and optimization techniques using Cisco WAS. It will happen at 10 a.m. Central European Time. And the expert is Gabriel. And during the live event, he will introduce techniques of WAN acceleration and optimization applications using the Cisco WAAS solution. The registration link is mentioned in the presentation, and it will be also available via the chat window. Another expert webcast happening in Japanese. The topic is Fabric Path Refresher from Fundamental to Virtual Port Channel Plus, VPC Plus. It will take place on Tuesday, January 29, 2013 at 10 a.m. Tokyo time. And expert Kaoru Yamashita will discuss Fabric Path, a specific protocol for new layer 2 network overcoming weakness of spanning tree protocol. Again, the registration link is mentioned in the slide. It will also be available in the chat window. And today, we are going to have the December Facebook forum. The topic will be configuring and troubleshooting MPLS traffic engineering with a Cisco expert Subhash Chopra. And he's also from HTTS DAC in Bangalore. And it will take place today, that is 9 a.m. Pacific time or 10:30 p.m. India time. And it will take place on the Facebook fan page. And the link has more info about what exactly going to cover. So feel free to attend and ask questions. The expert will be live for 1 hour during this time. And also some of the Ask the Expert events that is live currently. The first one is presented by Naman Latif, and the topic is data center and cloud security. You can learn more about the different solutions and best practices around security, securing your physical and virtual environment in the data center. This ends on December 21st. So feel free to use the resource and directly interact with Naman. There is another Ask the Expert on topic Cisco Unified Border Element UBE Enterprise, and with the expert is Robin Kai, and you can learn and ask questions about how to design and troubleshoot the Cisco Unified Border Element configuration for the enterprise in different call scenarios, including normal calls, hold resume, call transfer, call forwarding. This is also active till December 21st. So feel free to visit the expert corner in Cisco support community, and you can see various tabs. Just click on the Ask the Expert tab and feel free to ask the question and directly interact and get responses from the expert. All right. So we continue to expand our reach in local languages, and we have communities in other languages, including Spanish, Portuguese, Japanese, Polish, and Russian. So if you speak any of these languages, feel free to visit the community, and you can ask questions in the respective languages, and you can interact with experts who are participating there. The links are provided, and also it will be posted in the chat. So our presence in social media and iTunes keep expanding. So visit our community and visit several channels from there. So the link is supportforums.cisco.com, and you can see the presence in so many social media channels. And last but not the least, the correct answer that we have been asking in the trivia question. The question was, what is the connection between Cisco WLAN controllers and Apple? So the answer to that is, to cope with the rising tide of iOS devices trying to use Apple's Bonjour Discovery Protocol and enterprise networks, Cisco introduced its first next-generation wireless LAN products, the Cisco AeroNet 1200 series, and it's the industry's first dual radio wireless LAN access point. And it supports both IEEE 802.11b and 5 GHz IEEE 802.11a radios. This protocol enables Apple devices to query and announce specific services such as AirPlay, which allows audio and video to be shared between devices dynamically. And you can find more information on the cisco.com document that is mentioned on the slide, and we'll be posting that on the chat window as well. Okay, so before signing off, please take a few minutes to complete your evaluation of today's session. This will help us address your business needs and interests in the future. And this concludes our session today. Thank you to our expert Maitri for sharing her expertise with us today. And also thanks to expert Madhuri, Sharad, and Surendra, who joined a bit late, but he also responded to so many technical queries. So thank you all and have a nice day. Bye-bye.